Okay, so from F5 perspective, this is the last topic, LTM perspective. And then I will also cover HA troubleshootings. We generally don't cover in here, but I will try to
Recording
cover
started,
some.
right? Recording started, right?
Yes,
I
yes.
think, okay, thank you. Thank you. Okay, perfect. So everybody know about HA, like you guys also working professional. So here I will not focus much. I will focus on the F5 perspective. But yes, just for the brush up purpose, redundancy, everyone use in the company as a redundancy for the each device, even on server level, switch level, and firewall levels, load balancer levels, everywhere use so that it provides stability in the company. We can say like if one device goes down, still there will be no any impact on the traffic. So for that we use redundancy nowadays on each levels. Okay. So at the moment, every device is coming with redundant power cables, power supply, we can say. 1 minute. And even on ISP level also, nowadays we are using ISP level as also redundancy. If one ISP goes down, traffic will handle by another ISP. Okay, even on the disk levels, nowadays we are using, 2-3 disks for the redundancy purpose. So this is just for the picture of the RAID. RAID is basically redundant array of independent disks. Mostly I seen this in checkpoint devices. So actually it is going to be store all the things, all the details, data in the this hard disk, for examples, and it is going to be synced in this also. So if this goes corrupted, still our data will be not lost. So that is called RAID. It is nowadays coming the devices. So I have seen in checkpoint. Nowadays we have on switch level also providing redundancy with the channel, and if you are using on the working on the Nexus switches, so we are using VPC. Okay. So HA is basically same things. We are putting two devices in one place for the redundancy purpose. And then we have in LTM HA modes, we have active standby and active. So we'll see in our lab. And for you guys, I have wiped all the configurations. Like I will do, I'm going to do from the scratch, like VLAN interface, everything. So this will be our HA VLANs interface, or you can say like this will be HA VLAN, and 1.3 will keep our interface for HA in our lab also. We'll keep here one floating IP for outside, and we can keep floating IP here for inside also. So floating IP basically stands for VIP virtual IP. It is going to be, act like if you guys work on the HSRP, VRRP. So similar like in F5, we floating IP. It is going to be common for both the devices, and floating IP will act as a gateway for the outside peoples, and for internal floating IP will act as a gateway for inside peoples. So for example, if this box goes down, still there will be no impact on the external client who is accessing our backend application server, because this is the VIP IP, this is not the actual interface IP, and GR comes in the picture to get the things handles. Okay. Then we have active also set up, but mostly in the productions we have seen active standby setups. Okay. Yeah, HA prerequisite. Yeah, both devices should be on the same version, and try to keep same resources. So that will be recommended things. And there are some terminology in F5 which I will cover here. Okay, so I just mentioned, guys, HA is high availability. It has special features in F5 that provide redundancy between the F5 chassis. And if any failover happen, it will be not interrupt or impact in the operation of the systems. And HA feature ensure that application is available all the times. So of course, application is hosted behind our F5 load balancer. So For that, we use our device in redundancy so that user will not get impacted from the applications while accessing. Active extend two types of mechanism in related to HA in F5. And very important to understand two types of failover that can happen in F5. First one is network failover and second one is serial failover. Okay, this is very old one. No one is using these ones, but yes, for understanding purpose, we can see the theory, like what is serial failover. Okay, so serial failover, guys, if you come on the devices, for example, here, F5 LTM serial port. So there is one, see, this is the serial port, this one. Failover port is missing, like, but this is serial port. This is the now the net line interface port. So if you want to use this port as a HA, for that, we need to keep our devices closer. Okay, the distance between two devices should not be more than 50 feet. But this is very old method. No one is using this. So if you are using serial failover interface for the HA part, we need to keep both the devices, both the LTM devices together, not more than 50 feet. And hard, we can select serial failover cable is dedicated for HA use only. So we can use that port only for HA purpose. So whatever port I have shown here, this one, that is only used for the failover. And this box and another HA box should be in the like closure. So that is the work of serial port. But no one is using this because nowadays we are using network failover like LAN port, this port for the failover perspective, and we can keep our devices longer also. That is not issue. So this is about the serial failover. In case of network failover, a standby device will keep alive every 5 seconds by default to see if the active device is available. Okay. And if it does not receive response, then standby will become active. We can also change the keep alive timer. That is fine. Yes, we can also change, but we generally keep defaults on. Okay, it does not have any limitation like distance that we have in serial failover. Okay, so in network failover, there is no limitations. See this box LTM1, this box with LTM2. Maybe sometimes in our company, we are using switch in the middle. We are directly not connecting this LAN network failover, like for example, interface 3 directly to interface 3 directly to the another LTM boxes. We are keeping here as a switch, and this is the recommended design also, so that it's kind of a stability, guys. So generally we keep, like for example, in our lab we are keeping 1.3 for the HA port, 1.3 for HA for another box also. So here we can create one. We can keep one switches here. We can put this switches. We can select in the particular VLANs and same port this side also, and then we can connect here. Okay, but it depends, guys. It totally depends on your company and for your designs. But generally, we use switch to connect our port. We generally don't directly connect it. Okay? But we can directly connect also. That is also not great issue. But for the stability purpose, the guys use in the company in the middle as a switch also. And if you don't implement the HA properly, then it will become a split brain. So it is very important to see. Anyone know, like, do you know, guys, a split brain issue? What is split brain issue in HA? Not from F5 perspective, from any devices, routers, switches, everything. We can tell him here. I'm audible, guys.
Yes.
Yes.
So do you know the split brain? So split brain happen, like for example, just consider this is your one box, this is another box. Okay, and we have configured one port for the HA communications, HA sync purpose, right? And this is your active box, and this is a standby box, right? And this is active box, and this is a standby box. This box is not down, guys. This box is not down, but because of this failover interface, there is not getting proper communications. So this device is not getting any update from the standby peer. So it after the some particular time, whatever defined for the sync purpose, If this device will not get any response from this device, it will consider, okay, this device is down. And, for example, let's consider like that. This is active, this is standby. And if this device is not goes down, but there is no any update coming from active to standby because some issue on the failover interface levels where all the communication generally sync between two devices. So if there is no response received from active device to standby, maybe standby will think, okay, this device goes down, let me take the role as active, and this device will act as active. But still this device is active because there is no issue on device level, only sync communication has been broken. There is no any communication, only communication has been broken between devices. At that time, it will create a split brain issue because both devices are operational. And only it happened because of there is no any communication, no sync between devices. So that is called a split brain. So for that, we generally keep two things for the communication purpose. One we can use as a HA interface, another we can use a backup as an internal interface. So that if this interface has any problem, still our communication sync part will happen from another interface. So we'll configure in our lab one way. Okay, where both devices consider themselves active. See, I mentioned here, some connection goes to one device and a few other connection go to another devices, and that lead to outage in the operations, right? Sometimes happen in the company if you work, and maybe you notice. In my environment and my experience, guys, I have not seen this types of issue, but yeah, this is very important to understand. In HA active standby setup, a status of active device will be in green color, guys, and a standby device will be in very, very important if you are configuring devices in HA in F5, guys, and your device is physical devices, or maybe some physical hardware devices hosted in your on premises, maybe data center or in your company. And if you configure HA, your active device will be green colors and a standby device will be showing the yellow color. If it is showing in red, means device has been failed, something is. So active will be green and a standby will be yellow. That is the recommended one. That is the accepted things. That is the, if anyone tell you, okay, a standby device showing yellow, we can tell, okay, that is the recommended things. There is no any issue because this is how it is designed. And but if it's showing in red colors, okay, where is the color showing, guys? See, it depends upon the version. Okay, it depends upon the versions. Here there are some option like HA status, and there are so many things here, and it will be generally show like all the light here. So there is some option mentioned like HA and other stuffs here. It depends upon your device, like which devices are using in your environment. So there is a display option here. Okay, so we can see that here. So if someone reported, we can take peek. We can ask someone from the on-site, maybe data center people. Please share the snapshot, share the picture of the devices from front side and backend side, and then we can accordingly analyze it. Okay. Perfect. Any question till now, guys? So these are the F5 terminology. Okay, HA part we already know, like you guys already working on devices, so you know HA theory. Okay, it is very important to understand from F5 perspective how many things are in F5 while configuring HA. Okay. Then we have requirement for network failovers. So how many things are required for network failovers? Okay. So apart from the internal external VLAN, need to create dedicated HA VLAN for HA operations. So we generally in company or maybe in our lab, guys, here, if we come here, see earlier we have only worked on the DC external interface, internal interface, external interface, internal interface. Now we'll also use this interface. Okay, as a HA. So we need to create 3 VLAN, one for external, one for internal, and one for HA VLAN. And then we need to create 3 self IP, one for external self IP, one for internal self IP, and another one for HA self IP. Self IP is the things where we configure actual physical interface IP address. And then we'll create external floating IP and internal floating IP. External floating IP will common on both the devices, LTM1 and LTM2. So for examples, we are creating external floating IP 192.168.2.102. That will be same on both the boxes because this is what act as a virtual IP, not the actual physical interface IP. Same for the internal floating IP also. So we need to create internal floating IP same as both the boxes. For example, LTM1 and LTM2. Okay. And reason for the need of 3 IP addresses are below, guys. One IP will configure at active device. Another IP to be configured the standby devices. Third IP to configure as floating IP that floats between active and standby devices. So everybody know about floating IP. It is going to be float between active and standby. So if this box goes down, let us understand from here, guys. This is high level design. This is high level design. So these types of design we need to do in the company. Just consider this is our active box. This is LTM1. This is LTM1. And this is LTM2. This is LTM1. This is LTM2. Okay. These are the backend server, server 1, server 2, server 3, server 4, which is hosted behind our load balancers. And maybe we can connect through some, maybe we can connect through switch also, that is not the issue. So this interface is the internal self IP of the LTM1. This interface is the internal self IP of LTM2. In similar range, we keep as a floating IP, internal floating IP, in similar range, 10, 10, 10, 100, 10, 10, 10, 101, 10, 10, 150. That will be the virtual IP. It is going to be float between both the devices, active and standby. Okay. Same for the external, we need to configure as external self IP, that is the actual physical interface IP. External self IP, that is called actual physical interface IP of LTM2. And similar range of IP we keep as a external floating IP, that is the virtual IP. It will act as a, like we can say, like floating in between active and standby. It is very simple and straightforward. We don't need to confuse here. And then we can keep one dedicated interface for our HA communications. Okay. So this is the high level design related to F5 HA, guys. And now we'll see a little bit more here. It is very, very important, guys. Every time in interview also, let me just erase this. They ask questions like, if you want to deploy devices in HA, how many steps and how many interfaces are required? Okay. They generally ask questions like, how many interfaces and how many steps are required to build the HA in F5 LTM. So we need to tell, like, for creating HA, we need 2 devices. Okay. And we need 3 interfaces, one HA interface, one external, sorry, one HA, one internal, one externals, and one management. So that is the optional one. That is the, but we can tell, like, to deploying HA, we need 4 interfaces, one management, one internal, one HA, one external. Same for another box also. So once we explain like that, they can easily understand it. In that we can tell we need to create 3 VLAN, external VLAN, internal VLAN, HA VLAN, 3 self IP, external self IP, internal self IP, HA, and HA self IP. Same thing we need to do in the another box also. So these are the steps and prerequisites required while building HA on maybe cloud or maybe on the on-premises. Okay. What is floating IP, guys? So the IP I just mentioned, float between both active and standby devices, will stick to the active devices. Okay. So for example, this is active and this is a standby. Okay. See, this device goes down. The people who is coming from outside, generally we keep switch here, and then switch it will come to the F5 device, right? Maybe somewhere firewall also in the middle. So with the help of GR is going to be tell, okay, this box has been down. Now we need to keep this interface MAC address as active, and all the traffic will be routed to this box because this will work as a active if this box was down. So this is how GR and floating IP work here. There's very, very important traffic group, guys. So there are some terminology, floating IP and traffic group. So what is traffic group? Traffic group, there are 2 types of traffic. Traffic group local only and traffic group floating only. So what is the meaning of traffic group local only, guys? So it is a collection of configuration objects that belong to local F5 devices and it is not part of the HA. Example, self IP, VLAN and B. So for example, if you are configuring VLAN self IP, that will be part of traffic group local only. That is not going to be synced. That is not going to be synced to the another peer. Okay. So if your device is in the part of traffic group local only, means that is for the device specific. For example, creating VLAN, self IP, that will be specific for the single devices. It is not going to be synced to the peer devices. But traffic group floating only means it is a collection of configuration objects that can be float between the active and standby devices. For example, once both devices are in HA, and if you are creating virtual server, pools, profiles, iRule, SNAT, everything is going to be synced from active to a standby. But generally, self-IP that part is the common parts for the specific of the devices that is generally not synced, and also it is not recommended to sync that part. So that is called traffic group local only, which is for the device specific. Traffic group floating only means it is going to be synced the changes from active to standby. For example, virtual server pool for file and so this is the beauty of HA, right? We are doing configuration on one device and it is going to be synced to the another devices after syncing it, right? So this is about a traffic group floating one. Okay. Then we have configuration synchronization, guys. So it is a method to produce the latest configuration from one device to another device, mostly from active to standby. So for examples, these two boxes are in HA, right? This one is active, this one is standby, right? And if you're doing any changes here, for example, creating certificate, CSR, renewing the certificate, and once we are doing the sync part, it is going to be synced from the active to standby. That is all configuration synchronizations. What is mirroring? You guys can tell me what is mirroring, right? I'm not asking from a F5 perspective. Mirroring, we can tell from Palo Alto, Checkpoint, or other device perspective. What is mirroring? Any idea, guys?
Mirroring
No?
just like a all configuration should be synced from active to passive.
Actually, let me explain. Let me explain. Mirroring means let me explain here. This is your active box. This is your standby. And this is your HA interface. This is your active. Just consider like that. This is a standby. We have here switches. There are multiple applications are hosted behind our load balancers. Correct. For example, 50 people are accessing our application, and that session is active on active devices. Like TCP handshakes between front end to F5, F5 to the backend server. All those session is active here, right? Let's consider if this box goes down. So if this box goes down and that session will be not sync here, mirror here, all the 50 user will be impacted, correct? So mirroring is whatever session live is here, that will be mirrored to the another devices also. So that if this devices goes down, still that user will not face any problem and the traffic will handle by another box without any problem. There will no any service impact for the people who is accessing our applications, which is hosted behind our load balancer. So mirroring of the session is going to be, sync. So that is called mirroring. Active sessions, not the changes. Active sessions from the active boxes, it should be mirrored to the another boxes. So that if this goes down, still 50 users will not face any problems. Okay, so this is the work of mirroring. So connection and persistent information on the active device will be duplicated to the peer unit. So whatever the connections, persistence informations is on active devices, it is going to be mirroring duplicate to the standby devices. So in case of failure, the peer system can begin processing connection immediately without any interruption. So this is the work of mirroring. Okay, so in F5, HA is very, very simple. We need to only understand some terminology. Mirroring, configuration synchronizations, traffic group floating only, traffic group local only, floating IP. These are the important terminology in F5. We just need to understand it. And one more thing here, for example, there is device group terminology in F5. So device group name indicate we are putting devices in the group that is called device group. Device trust, guys. Device trust, like device trust represent trust relationship between devices, also known as trust domain. And basically, we devices get trust with the help of certificate. So device trust in local traffic manager is achieved by certificate-based authentications. So for examples, sometimes both boxes in HA, let's consider this is active, this is a standby, right? Sometimes, config sync, sync has been broken. So sync having broken sometimes happen because of device trust has been broken. So if you want to be sync should be properly, like whatever changes we are doing here, it should be synced properly to this device here. It is very, very important. Device must be right in trust. Okay, and they generally going to be trust with their certificate. So big IP system trust is prerequisite for both devices group and traffic groups to provide failover configurations. LTM network must be in the same trust domain. And in big IP system, initial trust of each device is performed over the management interface. Okay, so initial जो trust होता है guys, it is going to be performed over the management interface. So device trust is very, very important. If there is no any device trust, we can't build HA. It is very simple and straightforward. Okay, perfect. In failover, there are two types in F5: sync failover and sync only. Can anyone explain if you know just for the terminology, guys? Don't read this theory. We can explain on the basis of just sync failover and sync only. Okay, no problem. Let me explain. See, in case of sync failover, guys, both configurations, data and failover objects are synchronized. Okay, utilize traffic groups. Sync failover device group synchronize configuration data and traffic group data for failovers. Use this configuration to fully synchronize to big IP system local traffic managers. If active becomes unavailable, failover occur and a standby is able to instantly pick up traffic. So in case of sync failover, it is going to be sync the configurations, also whatever the objects we are changing. Okay, whatever the modification we are doing, it is going to be synced to the on the peer devices, so that if one active devices goes down, traffic will handle by standby without any problem. So it is recommended to use sync failover in the company, guys. Sync failover, right? It is going to be applicable for sync as well as failover parameter also. For examples, in case of sync only, it is only going to be sync the configuration. If device gets failover, then it will not, it can't create impact in our productions. It is only going to sync the configurations. It is not going to be helpful in failover. For example, two devices are in nature, this one and this one. Configuration will be synced, but if this device goes down or this device goes down, this will not become a because we are not doing anything related to the failover part. We are not syncing anything related to failover part. So if this device goes down, this will not act as active. So it is only going to be sync the configuration, not going to be perform the failover part. So that is the results we need sync failovers where configuration changes as well as failover object are also synchronized. Okay, so that is the work of sync failover and sync only. Traffic group I just mentioned, traffic group local and floating. You guys are now very much aware. Okay. Connection I have already explained. Configuration synchronization I already explained. Network failover I already explained. Floating IP I have already explained. And then we'll see these things. We can do sync through automatic and through manual. We see once we build our lecture. Okay. And then we can see incrementals. Okay. So this is about the HA theory and F5 terminology in F5, guys. So let me know if you have any questions. Then we can move ahead for our configuration part. Harish, Swapnil, and Sham.
Yeah, it's fine. It's fine. It's normal theory, right? We can go for the practical. Yeah.
Okay. Okay, so let me come to here, guys. So we access devices and 08 and
Surya,
Mhm.
I have provided the license in WhatsApp group.
Okay, okay. Thank you very much. Thank you. Yesterday I have wiped all the configuration because so I wanted to show you guys from beginning so that, and I forget to copy it. I should copy it, please. One box, this box license was valid next 30 days. That was my mistake. No problem. So this will be brushed up for you guys, like how we can do license. We come here and we can click on activate. And simply we need to just whatever Raman pasted here, let me copy on the notepad first. And we can come here. And paste here. Okay, and we can simply copy that. Same thing we need to do. First in my company, guys, I do from CLI because WebUI is not allowed there. It's very difficult. Okay. So manual, and then we need to click next here because we are doing through manually. Similarly, we can do here also. Then we need to copy this Dozier one. Control A and Control C. Click on here. For example, maybe your company, your Jombox and not internet connectivity. Then we need to copy this URL and paste on your laptop where internet connectivity is there. Copy this Dozier on this here and click next. And this is the license, guys, and we simply Control A and Control C. Maybe we can download and we can import also, but here this is live environment, so I'm simply copying and pasting here. And then we can next. So this is the way to do license devices. Okay, let's do for another box also. And we can copy here, second registration key. Can copy here and click on manual, then next. You can copy this to here, guys. Control A, Control C, click on the licensing server. So if click here, it is going to be redirected to F5 license server. You can copy paste here, you can click next. And we can copy this license key, Control A, Control C, and we can paste on these devices. And click next. Okay, so now it is looking good. And it is also loadings. So this is our big IP one. Okay. So this is the resource provisioning. But at the moment we are also only using LTM, guys. And in our next batch, we'll see DNS part. So at that time, so we enable it. So we keep as it is, and then we can click on the next. So this is LTM one box. Yeah. Okay, so this is device trust. It is automatically taken localhost local domains. We need to click now next. It will be the default one, keep as it is. This is the platform, guys, where we generally define the IP address of the devices. and like this is configured as manually, like statically. 137. This is the we can keep as it is. Host name, it is very, very important to mention, so that it is mandatory. It is required. F5 LTM1 we can put here. F5 LTM1 dot abc.com. Generally in company we keep DNS entry for that also. Perfect. And host IP address keep as it is. Time zone we can keep, I think, keep this one Indian. Keep anything's okay. Here it is asking you want root password also. Yes, I want it. So let me configure root password also, root account password. Root account, guys. See like username password. Okay. Let me keep same one, whatever I mentioned earlier. So star can do here. Okay, so I have done it, and then we need to click next. So in company also, guys, once you build any new devices, we need to follow the same process. This is the exact process we need to follow. There is no any extra things we need to do. Only thing is we just need to follow the company change process. That is the only things we need. Okay, I'm clicking finish here because before coming to the HA, I will first create our interfaces VLAN, then we'll come here. Okay, so I'm just clicking here finish. Same we need to do here also. And all the HA related things, guys. Okay, all the HA related things. Let me just, it is loading. And again, we can keep as LTM at the moment. Click on the next on another box also. Okay. So what we need to configure here? What we need to configure here, guys? What you need to configure here? What we'll do? This our box, this one, LTM1, LTM2. So we need to only configure this VLAN, this VLAN, this VLAN, this IP, this IP, this IP. Okay. Same thing we need to do here. And then we need to configure HA part. And once HA has been built, then we don't need to configure anything on these devices. We only need to configure here like virtual IP pool, node, everything. So it is going to be synced to here. Okay. But for the beginning, to set up the HA, to initial configuration, we need management IP, internal, external HA interface IP. We need to do on the same boxes, two boxes. And HA configuration, we need to do this boxes and this box both. Okay. So that is the only things we need to do on the two boxes. Apart from that, once HA has been built, we only need to do configurations on this box, and it is going to be sync on these boxes. Okay. Perfect. So then click on next here. That is fine. I'm here. I'm putting LTM2 dot same thing. LTM2.abc.com. I can keep same password. Extraordinary. Other 1, 2, 3. Perfect. And then we can click here next. See, host name has been changed, ltm1.abc.com, correct? So all the guys, if you come here in local traffic, if we just 1 minute. In device management, all the HA related things is here. Whatever I explain, devices, device group, device traffic group. So whatever I explain, so all the things in F5 HA related things will be available in device management. Okay. Then click here, finish. Okay. So first part, what we'll do, guys? First, we need to create 3 VLAN. So come to the network and then VLAN, and we need to create 3 VLAN first. Okay. So we'll create external VLAN and we can keep our interface 1.2. So first part is external VLAN. Okay. Keep as it is. External VLANs is a part of which interface? 1.2. we need to put here external is 1.2. Tagging, untagging means guys, it is just access port. Okay, it is just work as access port on the switch. Or switch, whatever we generally know about the access port, it is the same thing in untagging. Okay, so this is the 1.2 interface is the part of our VLAN external. Perfect. So we guys also try to consider here and keep consideration so that we need to follow similar step on another boxes. Otherwise, our HA will be not built. So whatever similar configuration related to HA we need to do in both the boxes. So external VLAN interface 1.2 and everything will keep as it is. Perfect. And click repeat because I need to configure another VLAN also. Internal VLANs. Internal VLAN is a part of 1.1 interface. Interface 1.1 and untagging. Perfect. And we can click repeat here. Then we need one HA VLAN. HA VLAN is a part of interface. Interface 1.3 is a part HA VLAN. So we can keep here like interface 1.3, add it, untag, and then we can finish it. So we have created 3 VLAN on one boxes. Okay, external HA and internal VLAN for active box. Same things we need to do on the another box also. So we'll do parallelly so that it will not create any confusion, guys. Come to the network, VLANs. And we can create here. First one is external VLAN. External VLAN, same LTM2. Interface 1.2 will be part of. One is the slot, 2 is the interface. Okay. So 1.2 is the part of external VLAN. So we'll do here 1.2 untagging add. Perfect. And we can repeat it. Then we can configure like internal VLAN. Internal VLAN that is 1.1. Interface 1.1. Perfect. Repeat. Then we need to create like HA VLAN and interface 1.3 the part of HA. Can keep 1.3 untag. Perfect. And click on finish. Okay, so we have created 3 VLAN guys. Okay, internal, external, HA. Perfect. Now we need to create self IP. Okay, 3 self IP and 1 floating IP. See, self IP we need to configure for the this interface, this interface, this interface, this interface, and this floating IP will be common for both devices. So let's configure first self IP and then we'll configure floating IP. So come to the LTM1 self IP. We can create here. We can give like first external self IP guys. And what is the IP address? I'm talking from the LTM1 perspective. So 192.168.2.100, right? So we need to mention here 192.168.2.100. So it is already there. We just need to just cross check. Okay, 2.100 and VLAN. Which VLAN? So external VLAN. Here we can select the VLAN. Okay, so 2.100. This one 2.100 is a part of interface 1.2 and it is the part of external VLAN. So we need to keep as a external VLAN here. Okay, port lockdown just keep as allow defaults. It is related to security guys, like how many portage are enabled on that interfaces. Okay, see here traffic group local only. See here non-floating means it is just for the local to this devices. It is not going to be float to the another devices. Okay, so that is see whatever I explained that is mentioned here. Traffic group local and floating. So if you click floating, it is create floating IP and it is going to be valid for both the boxes, active and standby. Okay, perfect. Service policy keep as it is. Then we need to click here repeat. What is saying? Correct the them before. Okay, it's saying like okay, subnet mask we have missed guys. So we need to mention subnet mask also. Okay, and then click repeat. So we have created external self IP, this one for LTM1 box. Then we need to create like internal self IP on LTM box. So we can give here internal self IP And what is the IP of internals? 1.100, right? So 192.168.1.100. This one. Subnet mask, same. This will be the part of internal VLAN. We need to select here. Port lockdown, allow defaults. This is the part of traffic local one, not floating. Then we repeat it. Now we need to create this one interface, HSL IP. Okay. So we need to give the name like HA self IP. We can give the name any guys, it depends upon you. What is the IP address, guys, for this interface 1.3? 3.100. 192.168.3.100. Okay. Subnet mask same. This is the part of HA VLAN. So we need to select here like VLAN. Okay. Port lockdown allow defaults. This is also part of non-floating, local only. Okay. Repeat it. Okay, I think we can finish it because we have created 3 self IP, external self IP, HA self IP, and internal self IP. It is very, very important. And then we'll create one external floating IP and one internal floating IP. That will be common on both devices. Okay. So let's create that also. Create here. And internal floating IP. What is the internal floating IP, guys? 192.168.1.102. We need to mention here 192.168.1.102. Subnet mask /24. Here we need to keep as a internal VLAN because this is internal floating IP, so we can keep internal VLAN. Port lockdown we can use allow defaults. Here we need to set like floating. Okay, here we need to select as a floating because this is the floating IP, and then we can repeat it. So we have created internal floating IP. Now we need to create external floating IP, and we can give like here external floating IP. And what is the external floating IP, guys? 192.168.2.102. This one. 192.168.2.102. 2.102. And this is the part of external VLAN and allow defaults. And this is the traffic group floating. And then we can finish it. So these things we need to do same configuration, guys, on the another box also. These boxes. Let's come here. So we have 3 VLAN created. Come to the self IP. And then create. Then first we'll create like external self IP. What is the external self IP, guys? 192.168.2.101. 192.168.2.101. 2.101. And /24. And this is the part of external VLAN. External VLAN, allow default, and traffic group local only, that is fine. And repeat. Then we need to create like here internal self IP. And internal self IP is like 192.168.1.101. 192.168.1.101. Okay. And that is a part of internal VLAN, allow default, local only, and repeat. Then we need to create like HA self IP, guys. And this is the IP of this interface. 192.168.3.101. 192.168.3.101. Perfect. And netmask /24. And this is the part of HA VLAN. This is default. This is also non-floating IP, and we can finish it. So we have created 3 self IP, external HA self, internal self IP, and then now we need to create 2 floating IP, one for internal and one for external. Same IP, whatever we have created there. External floating IP. What is the IP, guys? 192.168.2.102. 2.102 subnet mask /24. This is external, allow default, and this is the floating. Okay, and we can repeat it. And then we can create a internal floating IP, and we can keep here the 1.102. 1.102/24. This is the part of internal VLAN, allow defaults, and this is the floating IP, and we can finish it. Okay, so these are the basic things we need to do related to HA, and it is highly recommended. And same things we need to do on the production. Okay? There is no any extra things. Perfect. Now let's come to the HA part. So there are two ways to configure HA. First one is from here we can follow all the steps. Second step, we just click here on the F5 symbols, come here. And one minute, yeah. We can keep a run setup utility. Run config sync HA utility. I think this one is there. No, not this one. I think this one. Run config sync HA utility. This one, guys. So there are two ways. So we will follow from here, and we need to follow the same things on these boxes. Yeah, it is basically in the correct order, guys. That is the reason we don't need to remember the steps. It's better to follow this one. So click next, and it is saying for identity device wizard options for high availability, which method we are using, network failover or serial failover. So we are using network failover. See here, there are two options: serial cable, network, and serial cable network. So we are using network. Click on next. Okay. We have already created a VLAN, so that is the things we need to click select existing VLAN. Perfect. And this is selected external VLAN by default. Okay. So 192.168.100 255 allow defaults. Floating IP already selected by default. Interface everything. So internal, it is selected the external VLAN. After that, click on the next. Then it will select the internal VLAN here. We need to just select internal, and default gateway is there. Okay, floating IP already set, that is fine. We can keep as it is. And then this is the internal VLAN, and 1.1 is a part of internal VLANs, VLAN interface. Okay. 1 minute, guys. Internal VLAN is a part of 1.1. Perfect. Interface 1.1. 1.1 it is taken. It should be VLAN interface 1.1. So we can keep here. Okay. 1.1 already added. Okay, fine. Then we need to click next here. And now we need to select the HA, guys, HA VLAN. See, we have created here HA VLANs. So all the HA configuration related things, it is already taken. 1.3 is the part of HA. Then click next. Here it is asking like NTP server. This is not the mandatory. So here we can keep your NTP server as per your departments, as per your company. Click next. I'm keeping as it is. DNS lookup, it is take a default one. That is fine. Click next. And here it is asking for configuration sync, config sync configurations. Which interface you are using? HA1 for config syncs, right? Config sync configurations. Next. Same things we need to do on other box, otherwise it will not become HA. So it is loading. Okay, and this is for, guys, management failover unicast configurations. So for management failover, two interfaces is taken. First one is HA, second is interface. So whatever I explain, for example, failover things every 5 seconds it is going to be monitored to the from active to stand device. Communication will be synced between two devices in every 5 seconds, for example. So for example, it is syncing from HA interface. If this interface go down, it is going to be sync from management interface. Okay, so that is the reason here it is kind of redundancy. Okay, we can add, delete, modify as per your business, as per your design. Okay, then we can click next here. And for mirroring, guys, we use, I just mentioned about mirroring, HA interface, and backup we can use internal interface. And we can click next here. Okay, and then we can, perfect, we can keep as it is here. And then we need to do the same configuration here also. Click on next. This is the network. We need to take care, guys, same configuration should be in there. Okay, select existings. It is taken external VLAN, fine. 1.2, next. We need to select here VLAN internal. Perfect, click next. And now HA VLAN, guys. Perfect, click next. Perfect, INTP I'm keeping a blank, but we can keep NTP, India NTP server in your company, guys. Any company generally we have the local NTP server, right? Which is managed by the server team. Okay, keep as it is, 137.1. That is router, home router. And for config things, we reach here HA. Click next. Okay, perfect. And that is fine. HA and management, click next. For mirroring, second interface as a backup, we can use internal interface, click next. And now come on the here, click next. It is going to discover configured peer or subordinate devices. Once click next, it is going to be discover the peer devices, guys. So in company, see here, this is very important to understand. Once we click like device type, this is peer, and here we need to mention our peer device informations. Peer device IP address, username, password. Once it is going to be, once we're going to mention the peer device information, it is going to be retrieve information of peer. So in company, we can use management interface IP also, or we can say like HE interface, this one. So for peer, we are on LTM1. What is the HE interface for peer? 192.168.3.101, right? HE interface IP address. We can mention this IP address or management IP address also, okay? Because for failover purpose, we have configured two interfaces. So let me try to use peer IP address. So 3.101. So we can mention like 192.168.3.101. 3.101. And username admin and password whatever we have set on the boxes, guys, for GUI access. Okay, once we click here, it is going to be fetch your LTM2 devices details. See, everything is going to be fetch 3.101. So this is the peer device, all the details. Okay, device name ltm2.abc.com, add devices. See, once we have added, now see here, symbol got changed. Our HA has been built, guys. See, your symbol has been changed, awaiting initial configuration. This is active and in sync. And once it is done, If you come here, it will show like a standby and it is active and it will show a standby. Okay. See, setup completed. So this is online active awaiting initial sync. So once we will sync, it is going to be synced properly, and this will act as active and this will act as a standby. Okay. Come to the device management, device group. This is device group created. Sync failovers. The two members are added, LTM1, LTM2, right? Group type sync failover. I have explained what is sync only and sync failovers. Okay. We can do any advanced related thing. Sync type is manual with incremental sync. Manual with incremental sync, guys. For example, whatever changes we are doing, that is only going to be manually we can sync to another peer, that is called manual with incremental sync. Manual with full sync, that is not recommended ones. Okay. Because we only sync the changes whatever we have done, not the all changes every time sync, right? That is not the recommended one. Whatever changes we are doing, that only will be synced to the peer, not all the changes every time. Correct. So we need to keep manual with incremental sync every time. If you're using this one, automatic with incremental sync means if you do changes on this box, automatically it is going to be synced to the peer. So that is not a good thing. So always keep manual with incremental sync, and it is also used in the production. Okay, and we can update here. This is your device group. Okay, perfect. If you come device trust, this is the trust between two devices. Okay, so all devices in this group are in sync. If it is not sync, it is broken, then we can't means something issue on our HL, something issue with our devices. Then we need to check the certificate, interface, like HA interface, management interface. Okay, why sync has been broken? Okay, why trust has been broken? Then we have traffic group. So this is traffic group 1. See guys, here we can order the failover order. Okay, failover order. So you want to keep LTM1 as a always act as a active, and LTL2 always act as a standby. So this is the failover order. Okay, and then we can save it. Save it here. Perfect. Correct. Here it is showing online standby, changes pending. That is fine. Come to the local traffic, virtual server. Perfect. Once we click on the changes pending here, there are two options to sync, guys. See here. Push the selected device configuration to the group. So we at the moment tick marks on the LTM1 means we are syncing. If we try to click sync here, it is going to be synced from LTM1 to LTM2. So all the configuration, whatever we have done, it is showing timing also. So in the company, sometimes we start doing changes, and here it is showing changes pending. Don't do any changes, guys. If it is showing changes pending, try to see who did these changes and who did mistake, like they forget to sync the changes. So if you see here, configuration has been done on this date, this timing. So with the help of audit log, we can go in this timing and find out like who did the changes, who from your company, who from your team did changes. Accordingly, we can ping him, call him, and ask like what do you do the changes on the F5. If he will say okay, just the certificate renewal CSR, I forget to sync it, kindly sync it. Then after her confirmation or his confirmation, we can do the sync and then do your changes. We can't blindly do changes if it is in pending. Okay, click on the sync. This is the device group, guys. Okay, so once you do it, it's going to be sync from LTM1 to LTM2. Click on the sync. It is syncing. Perfect. And login again. Now it is a standby and in sync. it is active and syncs. So this is the beauty, right? This is the beauty of HA. Let me do some changes, guys, and then we'll try to do failover also. So we can create one virtual IP and we will create 3 nodes, server 1, server 2, server 3. We'll create one pool and we'll create one virtual server. Come to the LTM box. Once we are going to be synced, it is going to be synced from the active box to a standby. At the moment, there is no any virtual server here. There is no any pool here. There is no any node here. We'll do changes here. We'll first create 3 node. We can create 3 node here. We can give, for example, server 1. What is the IP address server 1? 1.1, 192.192.1.1. Health monitor not default, fine. We can repeat it. We'll create server 2. This see here it is showing changes pending. Once you do any changing, it will show there. Server 2 and IP address is 192.168.2. No defaults, repeat. Then server 3. And we can keep IP address like 192.168.1.3. No defaults, we can finish it. So we have created, guys, 3 server. All are off. Okay. 3 server has been done. Then I would come to the pool. Create one pool. We can give here HTTP pool, HTTP_pool, and we can as a TCP, because on top of TCP, HTTP work, right? TCP and round robin load balancing method. Node details we have already. Node 1, just simple add 80 services HTTP, and we can add it. Same thing we can do for node 2, node 2, node 3. So we have added 3 noded. So 3 pool member added in HTTP pool. Click on the finish. So we have created 3 node. 3 node has been created. 1 pool has been created. Perfect. Now we need to create virtual server. Create one virtual server. We can give name, for example, HTTP virtual server, and type a standard. Source is any, because we are not sure who is coming from internet to access our application, which is hosted behind our F5. Destination we can keep 2.200. Similar range IP address, guys, we need to keep from the outside interface IP range 2.200. Fine. We are trying to use 80, and port we are trying to use HTTP. Perfect. And protocol TCP client profile keep as it is, and I already covered these things. And we can use here non or maybe auto map, that is fine. And here we need to attach the pool, guys. So whatever pool we have created, we attach here, or maybe we can go on the resources and we can attach there. So there are 2 options to attach, and then we can finish it. So we have created it, and now let me sync these changes. See, if we sync it, whatever changes we have done there, it will be synced on this box. See, node pool. Why node is showing like this, guys? Because for this node at the moment, we are not using floating IP as a gateway, because at the times of lab, we have modified in gateway of all the server 1, server 2, server 3 as a self IP of this interface. So in case of HA, generally floating IP should be gateway for all the backend server. Okay, perfect. And yeah, it's looking good. Let me know if you guys any questions. In HA part, guys, till now. Any questions? I hope you guys are getting right.
Yes, clear.
Today Harish is timing. Like Harish. Harish, are you there? Today is Raksha Bandhan in India, guys. Okay, so if no question, then let's move ahead. We'll do some other things also. So let's try to do modification. I want to put this server gateway as a floating IP, internal floating IP, and for this client PC, we'll keep gateway as a external floating IP. Okay, so let's do changes. So I'm server 1. At the moment, default route is 1.101. So what I'm doing, configuration terminals and no IP route, no IP route, and no IP route 0.0 192.168.1.101. Instead of that, we can use IP route. Instead of that, we can use IP route 1. What is the internal floating IP? 1.102. 1.0. Sorry. 1.102. Hit enter. Perfect. Exit it. And we can write it. Similarly, we can do on the 2 more server also, guys. Okay, wait sometimes. Let's do changes on another box here also. So on server 2, 1.102. Okay, what we mentioned, guys? Okay, 1.102. We should be pingable also. Yeah, that is pingable. Perfect. Reachability should be there. Okay. Well, we can do changes on the server 2. Enable. Swipe it out. Swipe it out, and then we can change the route, guys. And no IP route 0.0.0.0.0. And we can remove this 192.168.1.101, and we can use IP route here. What are the IP? 1.102. Sorry, 1.102. 0. And exit it. Can save it. And it should be pingable. Ping 192.168.1.102. Should be pingable. Yeah, perfect. Let me do the same changes on the server 3 also, guys. Enable, swipe it out, and we can remove this default route. No IP route 0.0.0.0 and 192.168.1.101, and we can keep here like 102 and remove the no from beginning. Simply we can remove this, exit, save it. Perfect. Then we can try to ping it. Should be pingables 192.160. Correct. Pingable. Now health monitor should be in green, and otherwise to check here. TCP members. Oh, okay. So we have it is showing green properly. I'm not sure where here it is not showing. Default.
Maybe you have to enable the HTTP on server. HTTP services and HTTP services.
Yeah, HTTP service already enables. So
Okay.
no default is the no default means ICMP ping by default is allowed. So now everything, because we have do monitors on the pool level, right? So see here, pool is looking good, and inside pool member is also looking green. So this is not, there is no problem. It is perfect and fine. But I want to see like this should also change, because by default ping should be there, right? Server 1 and F5 communication should be there. If you click here, click on the capture, click on the interface. This is the active box, right? Click on the capture. And if you do on the interface 1.1, so communication will be happening perfectly, right? 1.1.100, because we are using auto maps, so everything is perfectly happening. So there is no any problems in between our F5 and the backend server. And maybe after some time it will come, or and node default, node specific. If you do here node specific, it will try to do gateway ICMP, guys, and update it. And if you click on the node, now it's showing us are green, right? Because I don't know why what was taken on the node specific. So node specific, and on the do the monitoring on the node level. But in company we don't do monitoring on the node level, guys. We do on the pool levels. Okay, you can use here and you can update here. And on the node 3 also we can do like that. Perfect. Node specific, and we can do gateway ICMP. Perfect, and we can update it. Right, perfect. Okay, and if you do the changes here, guys, if you do changes pending sync, whatever changes we have done, it is going to be sync from the active to standby box. Okay, perfect. The sync, guys. So if we come to virtual servers, all the things is sync here, like node pulls everything's here. See, everything is fine. Let's try to test it. Come to this VC. For this VC, you need to change the gateway to 2.102. Come to this VC, guys. Come to the terminals. ncpa.cpl, and we can change the gateway. So if it is net 0 means this one, it is loading. Right click, properties, and then IP version 4, guys, properties, and gateway we can change it here 2.102. Put 102 and click OK. Close. Open the browser. And if you click here, restore. Can use another tab. HTTP. I can test ping also. 192.168.2.200. Sorry, 2.102. Gateway should be pingables. Okay, we have mentioned wrong thing here.
Maybe that switch is off. The sense in between the switch.
Yeah. Perfect finding, Haris. I was thinking, where is Haris? Perfect finding. Perfect finding. Switch was not off. Yeah. Perfect. Good catch. So once switch will be up, it should be pingable, guys. At least it will take 1-2 minutes. Now it is pingable, perfect. And if you try to access it, it will be accessible, guys. There is another tab here. TPP. Now it is accessible, right? Perfect. So this is the ASA. Okay. So everything is working perfectly. Same things we need to do in the production, guys. Okay. Let's try to explain a little bit troubleshooting also, so that I will finish our LTM part today. Okay. And turn up tomorrow. Maybe our session will be not there. And from next weekend we'll start DNS, F5 DNS. And after covering, if you guys have any doubts, like if you want a little bit more in LTN, some more troubleshooting, we can comment that topics and I will try to cover it. That is no any problem. So this relation is not till our training. Okay. We'll be communicate always. Don't worry about it.
I see. Actually, today was a little bit outside also, anyway because of the some working here.
Yeah. We can ask anytime, no problem. We can cover like I will take one doubt session,
No
like for
problem.
1 hour, 2 hours, and we'll cover it. Okay.
Next week I will be traveling to UAE. Okay, so like Sunday I'll be traveling, so I'll be busy on next week also. Maybe tomorrow we don't have the training, right? It's this is last session.
Yes, tomorrow will be not. Next weekend we'll start DNS or once we will be available.
Next week we can make it like after a week we can start. Like next week we can skip it. What do you think, guys? Like
Okay, fine, no problem. So after next week we can start our DNS.
yeah, we will start from 23.
Yeah, that is fine. 1 minute, let me check it. 23 start. Okay, so next weekend is 16 and 17. Okay, fine.
1 week we can
Perfect.
we can watch the videos, everything, and let's see anything doubt also we can
Yeah,
start.
any doubt? Then first we'll cover that doubt, and then we'll start our DNS.
Then meantime we can
Okay.
Okay.
Perfect. So let me explain like how we can do failover. Okay. So for example, this box is active and this is a standby. While doing upgradations, what is our best approach? Generally, we try to upgrade our standby box, right? And while upgrading, guys, we generally do this part. If you come to device, this is your device. This is your LTM2 devices, right? If you come to here, there are options like force offline. If you keep force offline, it is not going to be down. It is going to be just broke the sync communication between active and standby. So while doing upgrade, try to do force offline, then upgrade your devices, then release from offline, and then come to these devices, active one, self one, then make this device just standby. So once you do force standby, it will going to be failover from this box. After some time, this will be a standby C, and this will become as a active. Now it is active. Okay, so at that times, all the traffic will handle by this box. So this box we have upgraded. After upgrade, we have done the failover from active to this box. Now traffic is handled by this box. Now we need to properly upgrade this box. And once it is upgraded, after post line, we need to upgrade it. Once it is upgraded, release from offline, and then again come on these devices, come to device, click on LTM2 box and click force standby because I want to make that box again active, which was there earlier. So now it will again become active and is sync. So this is how we can do the failover. Okay. Let me know if any question, guys. I hope you guys getting my points, and this session is informative for everybody.
Yeah, almost understand here. We will do the more practice as I said earlier also. Let's see.
Yeah.
Yeah.
Okay, so now come to your troubleshooting. So let's 10-15 minutes. See, in company, how to identify the cause of failover, right? I want to like cover so that these things did I not cover anywhere, but I want to do all the things whatever I do in the company, so that you guys can be crack in an interview and do same things in your productions. For example, how to identify the cause of a failover. So when failover occurs, we need to know what happened, why it happened, who did it. Sometimes manually did the failover, but we don't know. There are 10 members in your group team, but we don't know who did that. Okay. So when failover occur, we need to know why it happened. So how we can identify what cause of the failover was, we are going to find this is okay in these sessions. Okay, so there is one services guide in F5 SOD, switch over domain, and this is the service which caused to change the from active to standby. So SOD is basically because of SAD. So if any happen, for example, active to standby failover happen, with the help of SOD services, we can find that. So SOD is a service, switch over daemon service in F5, basically which cause the changes from active to standby is going to be tracked here with the help of SOD. So this services, it is going to be tracked the failover from active to standby. It is simple and short. For that, we need to debug it, enable debug it, TE message modify sysdb failover.debug value. By default, it is disabled. We need to enable it. Once we enable it, and if a failover happen, we can check the log. So let me do that. So this is the command to enable the failover debug, guys. And this command to enable the peer state so that we can see the peer related things. TE message modifies is dv failover.print peer state value enable. At the time it is disabled, but we need to enable it. And once do your debug, once you do troubleshooting, it is highly recommended to again disable it. So at the moment on F5 it is disabled. We'll try to enable it, and then we can see the logs. Okay, how we can do that? I will share this guys notepad to you. Don't worry about it. So the failover debug setting in the F5 system database is debugging parameters. So failover.debug is a debugging parameters, and it controls the level of logging and visibility into failover operations. Okay. So when enable, it provides detailed diagnostic information about failover events, helping administrator troubleshoot high availability issue. So once we enable this debug, it is going to be show more details related to administrators and troubleshootings. Okay, so this is the meaning of this one, guys, failover.debug. It is just setting in the F5. Once we enable it, is going to be some more details. Same thing, failover.print peer state. It is going to be variable that control whether peer state information is printed. So once we enable this one, this debug, it is going to be print all the peer state so that we can do analysis at the times of troubleshooting. So let me access our devices through CLI, guys. 192.168.137.108. This is our active box. We can access it. Let me increase the size, change settings, variance, and we can click here. And we can log in here. Right, it's okay. So it is showing here, it is active and in sync. Perfect. So if we run this command, guys, we need to run this command tmsh modify. Instead of disable, we can use here enable. enable. Okay. And okay, before that, let me do the failover. Come to devices. This is LTM1 box. And force to a standby. Yes. Come here. Enable. I've enabled it. Same things we need to do here for peer state. I'll share all the command. Enables. And we can enable it. Perfect. We have done it. Now, and we can check first SOD log, switch over daemon logs. Just filter this command, copy it and paste here. Okay, so it is going to be so like some details, guys, here, like a standby, and a standby. This is about 137.108, and let me find more here. So it is going to be show the state. So this is 137.107. So this is the this is 108, that is our active one. Now it is showing steady standby. This is showing a standby, but here it is not showing much detail like white 7 failover and all. So let me try to grab this log, this commands, guys. This one, warlog LTM, and inside warlog LTM log, I want to try to see SOD related things, switch over domain. Yeah, if you run this now, it is showing more output, right? It is more output, and one thing we need to find here, see here, in command go standby GUI. So someone has through GUI make this device as a standby. So it is clearly tell that it is happened not automatically. Someone has done it through command. We can select through GUI to make as a standby. So this is how we can at least find little bit like how why it happened failovers. Okay, what was the cause? This is the basic things we need to do, guys. Same things we can run on the another box also. Let me log into the these boxes 192.168.137.107 and row. Perfect. Here we can run the same command. We need to just we need to do same things here also. And enable it. And we can do the same things here, guys. And after that, we need to disable it so that it's going to be take unnecessary logs, generate unnecessary logs, and keep our space utilized. And we can do cat and then var log LTM and then grep SOD. See, it is showing so many details, right? If you do the session increase, let me just increase the size here. Perfect. That is fine. See here, command through someone has done to make this standby through GUI. So this is how we can do and find the cause of failover in the production, guys. Okay, we can also see these things. This log, guys, to find the sync related things, grep sync. If you run this command, cat warlog LTM, and inside warlog LTM log, I want to see related to sync part. We can just copy this and come to your boxes, or maybe these boxes, and we can do here. So it is going to be sync all the things related to sync, guys. Like we can do analysis, sometimes take help from vendor also, don't worry about it. So everything is going to be shown here. For example, this system update the configuration device group, and one thing I want to show here, sync cookies, perfect, peer villain hardware, sync complete the system you have written the configuration device, and let me run again. Perfect. Sync cookie protection is failed to enable. Perfect. Okay, and same things we need to run on this box also. Let me restart this. And can run the again commands. Right. See here it is showing like local, it is sync properly, it is sync properly, and there is no any problems. So this is the active box. Okay. So accordingly we can find it, right? It depends upon the issue. Okay. And then we can also do this to see the MCPD. Okay, MCPD is the daemon, guys. it is also responsibility to do our HA. So we can see it should be always running. It should not be a stop. If it is a stop, means the cause of failover, the cause the HA broken. Okay. So if you see here, and it is going to be so many details, more details here, and the status of within the trust devices within the trust is looking good, perfect. We can see check the status of the MCPD. Big start is the command to check big start status MCPD. This is the command to check the status. So it is showing like MCPD is running. It should be always running, guys. Okay, if it's not running, means HA will be broken. HA will be not fixed. So these are the things we need to see and do in the production also. If you want to find the cause of failover on F5 LTM, guys. So I hope if you guys are getting and it is helpful for everybody.
Yeah, that's great, Surya. Almost we understood,
Yeah.
since we came here as a nothing, right?
Yeah, I'm pretty much sure you guys now crack any interview. Also, once we start doing the work in the company, I'm pretty much sure you guys can do something better, similar like me, which I do in the company.
That's great. So,
Yeah. So that's it for today. And Rahman, we can share the recording and in the group, and I will share all the details in the group. And let's meet on 23 with our F5 DNS apart. See, F5 DNS will not do much longer, guys, like LTM, because DNS is